This video is a follow-up video to the last video on adding, subtracting, and multiplying complex numbers. This topic will be on dividing complex numbers. To get started, the first thing we need to understand is how to find a conjugate. A conjugate, if you take a look at this rule, it says the conjugate of a plus bi is a minus bi. The conjugate will allow us to simplify things that otherwise we would be unable to do. So understand that whenever we are finding the conjugate of an expression, all we are doing is changing the operation between the two terms. We are not changing the sign of all the terms. Notice positive A still remains positive A. However, this plus changes to a minus. So keep that in mind as we are looking at finding the conjugate. So let's practice this a little bit. You can see that we've got the expression 3 plus 4i, and I'm asking you to find the conjugate. The conjugate, again, we would just need to change our operation. So our conjugate of 3 plus 4i would be 3 minus 4i. Next, the conjugate for negative 4 minus 7i would be negative 4 plus 7i. Note that we are only changing the operation here. Here we have 5i. Well, if you think about what that means, we could think of it as our real number being 0 because we don't see an a value. And we could either make plus or minus here, 5i. If we were to find the conjugate of that, that would just be 0 minus 5i. So by dropping the 0, because adding 0 doesn't do anything, we recognize that if we have 5i, the conjugate would be negative 5i. So we are changing the sign of our imaginary part of our complex number. Next we have 6. If we're asked to find the conjugate of 6, it would just be 6. Why, you might ask? Because 6 plus 0i is the same as 6 minus 0i. 0 times I is 0, 6 plus 0 is 6, and 6 minus 0i would be 0 times I, meaning 0, so 6 minus 0 is also 6. So whenever we see a number, the conjugate is the same. That's the A part, remember, and this is the B. Okay? So finding the conjugate is going to be particularly helpful when we are dividing. So if we take a look at this example, 7 divided by 3i, what I want you to think about is remembering from what we know about radicals. If you recall from Math 2, the reason why we need to learn this division process is essentially that I is really the square root of negative 1. And if you recall in Math 2, a division by radicals is not allowed, so we want to rationalize, which is where we multiply the top and the bottom by a convenient 1, allowing us to then eliminate the radical from the denominator. So we're going to be creating an equivalent expression, but using our conjugate to do so. So this was to show you that we had a radical in the denominator, so I don't want you to worry about what that means. So let's just stick here. If I'm giving you 7 divided by 3i, actually I shouldn't have put equals, we need to multiply by a value that equals 1, so we are not changing the value of the expression. To multiply by 1, that means our numerator and our denominator must be the same. So when we divide, we always divide by multiplying both the top and the bottom by the conjugate. Recall that the conjugate of 3i would be negative 3i. Just like we just explained. But if negative 3i is what we multiply by on the bottom, we must do the same thing to the top. Now if you take a look at what we've just created, we've created a fraction whose value really is just equal to 1. So multiplying by 1 does not change an expression's value, but you can see that next what will happen when we multiply our denominator, 3 times negative 3 will give us negative 9, and I times I gives us I squared. Remember that from our lesson on multiplying. So I'm just going to continue to simplify the denominator so you'll see the purpose in what we're doing here. Recall that I squared equals negative 1. Oh, Now we don't have I anymore, which means we don't have a radical in our denominator. So when we continue to simplify our denominator, negative 9 times negative 1 is positive 9. Now remember, just like we multiplied our denominators together, we must also multiply our numerators together. We can multiply 7 times negative 3. Remember, terms do not have to be like terms in order to multiply. And include our I. So our numerator will be negative 21I. There's nothing really to simplify, so we continue to bring it over. And if we notice a common factor, we should reduce. So notice that 21 and 9 are both divisible by a common factor of 3. So if I divide my numerator by 3, negative 21 divided by 3 is negative 7, and 9 divided by 3 is 3. And that's the completely simplified expression, negative 7I over 3. So notice now we basically had a radical in our denominator in the form of I, and now by multiplying the top and the bottom by the conjugate, we have eliminated it, so this is our final answer, negative 7I over 3. So for 29 here, to get started, the first thing we should remember is laws of exponents. Whenever we're dividing the top and the bottom by the same variable, we can apply our law of exponents. In fact, our quotient property says that when dividing I cubed by I squared, that we actually subtract the exponents. But to help you understand what that really means, I'm going to expand out I cubed, because remember, exponents simply represent repeated multiplication. So this is 4 times I times I times I over 5 times I times I. Remember, though, that any number divided by itself really just equals 1. So basically they cancel out, leaving 4I over 5. Because there's no longer an I in our denominator, we are through. So remember, your goal is to eliminate I from the denominator. So let's write that down. Your goal is to eliminate I in the denominator. Pause if you need to get that down, because I'm going to move on. All right, next we're going to look at how we simplify a problem when we have the complex number with our real and our imaginary part. So we're trying to simplify negative 5 plus 9I all over 1 minus I. So again, because we have I in our denominator, that tells us we need to divide. But in order to divide, we must multiply the top and the bottom by the conjugate of the denominator. And let's just make a note of that. Multiply by the conjugate of the denominator. We never find the conjugate of the numerator. Multiply by the conjugate of the denominator. So if we are looking for the conjugate of 1 minus I, then we can just switch our operation and use 1 plus I. Whatever we use on the bottom, we also use on the top, remembering that the whole point is really we're just multiplying by the number 1, which does not change the value of the expression. What we are going to need to remember to do here, though, is we're actually multiplying binomials together. So that means we have to remember our process for doing so. To do that, we multiply the first terms together, so we're going to double distribute. So I'm going to come down here, and we're going to write that negative 5 times 1 is negative 5. Negative 5 times I is negative 5I. Then multiply 9I times both terms, distribute that. So 9I times 1 is positive 9I. 9I times I is positive 9I squared. We are going to simplify that, but let's go ahead and repeat that process in our denominator. So 1 times 1 is 1. 1 times I is positive 1I. It has an understood 1. We don't need to write it. Now distribute our negative I times 1 would give us negative 1I. And then negative I times I is negative I squared. So we should always look for terms that we can combine, and also we need to remember that if we have a power of I other than I to the first, we need to try to simplify that and substitute. So if we look at our numerator, we should recognize that we have I squares in both our numerator and denominator. That should remind us that we can substitute negative 1 for I squared, remembering our values that you were supposed to remember in your Powers of I video. So that means I'm looking here at I terms that I can combine, but this 9 times negative 1 gives me negative 9, which I can then combine with my negative 5. Remember that we always state the real part first, then the imaginary part. So negative 5 minus 9 is negative 14, and negative 5I plus 9I is positive 4I. And that takes care of our numerator. So really just using polynomial multiplication here. Now looking at our denominator, if you take a look, we have I minus I in this expression, which means it's going to cancel. So really what I have here is 1 minus I squared, but remember that I squared is negative 1. Remember, whenever you are subtracting a negative, that will actually turn to addition, because the opposite of subtracting a negative, that's their opposite, so it's going to turn to addition. So 1 plus 1 is 2. So we've now simplified our numerator and denominator, but if you take a look at all three of these numbers, you should notice that they're all divisible by a common factor. In fact, they are all even, and since our denominator is 2, we can use 2 to simplify. So that means I'm going to divide every term by 2. So 2 divided by 2 is 1, 14 divided by 2 is 7, and 4 divided by 2 is 2. Leaving me with negative 7 plus 2I all over an understood 1, which I do not need as a denominator if it's just a 1. Otherwise, I would leave it as a fraction. Since I have now eliminated all i's from my denominator, I am done. So what I'd like for you to do is pause the video. If you need to, re-watch me work this problem, and then try this one here, 31, on your own. So please pause it now. And then when you're through, resume the video so that you can check your work. So hopefully you've been able to follow my work. I'm now going to complete this and finish simplifying. So combining, remember that 15i squared is negative 1. 15 times negative 1 is negative 15. Since these are both constants, I can combine these terms. So I'm going to get negative 9. Then I'm going to combine my I terms and get negative 19i. On my bottom, notice that when I double distributed, I ended up with opposite terms, meaning a negative 15i and a positive 15i, which then will cancel. Negative 25 times I squared, where I squared is negative 1. Negative 25 times negative 1 is positive 25. add the 9, and we get 34. So our denominator is 34. So remember that when we finish, we should always have our real part, then our imaginary part to make up our complex number. And what should actually always happen is it should always end up being over a constant. So if you end up without a constant on the bottom, you've probably made a mistake somewhere. So this video concludes dividing complex numbers. Please feel free to rewind and re-listen to any portion to help you better understand. Thank you.